Welcome back to another video from Insectech's Android application penetration testing course. With this video we're going to start a new module, Introduction to Native Exploitation on Android. So basically in this module we're going to see how C++ developed applications can be exploited on ARM platform. Right. So basically before getting into the attacks and vulnerabilities or building NDK applications, let's have a look at the security enhancements made by Google to Android applications. Right, so this particular screenshot has been taken from official source.android.com, as you can see here. So this is where I have taken this from. Now if you observe this, Google has started making enhancements to Android right from Android 1.5. If you observe the first one, Android 1.5, they have actually implemented something called F-Stack Protector to prevent stack-based buffer overflow attacks. And I'm not going to walk you through every single line in this page, but rather I'll just give you a high-level introduction to what Google has done to prevent C++ based attacks, memory management or memory corruption attacks. And in Android 2.3, if you observe this, format string vulnerability protections have been added, where if your application is vulnerable to format string vulnerabilities, it will automatically throw an error where it says, hey, format security error is there, and it won't be compiled. And then hardware based no execute to prevent code execution on the stack and heap. So NX basically stands for no execute. It doesn't allow any code to execute on the stack or heap, right? So generally when we run buffer overflow attacks, when we write buffer overflow exploits, we have to run some sort of machine code on the stack. So this NX bit, and it is hardware based, of course, this NX bit allows, this NX bits prevent this kind of shell code which executes on the stack or heap, right? And if you observe this Android 4.0, they have made even more advanced enhancements by implementing something known as and address space layout randomization, which is even more sophisticated defense against buffer overflow attacks. And even in Android 4.1 they have implemented position independent executable support as well, right? So these are the few things that I can show you before actually getting into native exploitation. Of course, as you can see, it is highly difficult for us to exploit applications on Android platform, but the concepts that we learn here will actually be helpful on hardware attacks as well as any attacks on any other ARM platform. It doesn't always need to be Android, but before performing the attacks in this particular module, we'll disable the security checks on Android, right? So let's go back to the presentation. So these are the memory management security enhancements made by Google to your Android applications. So that's all I have in mind for this video. Thanks for watching it. Thanks a lot.